Welcome back to Moko Plays Satisfactory. So last episode we got power upscaled, ready for things to expand in a big way, and then we went ahead and unlocked blueprints, the blueprint designer, and made our first couple of blueprints in there. And since then, I've done a little bit more messing about with the blueprint designer. I took our basic concept of the smelter kind of array that we had and did something very similar with 8 constructors in that same kind of walled off square, I guess. And I've been messing about with that offline and found a couple of issues with it, which has me a little confused as to how we're going to proceed with blueprints going forward. So let me show you what I mean here. Come into blueprints and we go first to floors to lay our basic kind of pattern foundation that we did. First thing is we've got two build modes here. We've got the default build mode, which kind of lets me align and snap things around freehand like this. And the second build mode, if I tap R here to change, is blueprint mode. And this doesn't behave any differently when we're only laying down our first thing. The difference seems to be is that it wants to snap directly to other blueprinted items when you go to place additional ones. So right now this is snapping purely to the center of the existing foundation that we've laid, and I can't kind of move it to be misaligned. I can place it next to that. There we go, that's kind of more what I was aiming for. Now if I toggle out of blueprint mode and go to default, it does let me kind of place this on top, but misalign it by increments, much the same as if I was just placing one non-blueprinted item on top of another. First thing to highlight here really is this is incredibly challenging to try and place things correctly when you're dealing with a 4x4 square of stuff. Like you kind of want to be further away, and there's just not a particularly clear feel as to what am I actually controlling. Am I controlling the center point of the blueprint? Am I controlling the bit that's nearest to me, or what? It's pretty unwieldy. The other thing that I noticed, and this was maybe an oversight in the way that I was thinking, was that we built our smelter design. If I just load it up in the blueprint designer here to show, which we do like this. And then let's just get rid of some stuff so we can see. We built this directly onto the bottom of the blueprint designer. We didn't put any foundations down there, with the assumption that we were going to lay foundations and then kind of lay the blueprint on top. And that's made it behave a little bit quirky in a couple of ways, I think. Let me just clear out of that. So what we've got, if we do go and place that blueprint in the world, is, again, if I toggle back to blueprint mode, you can see how it snapped immediately to the other blueprinted item that we'd built. We get that. We get our first floor of smelters built incredibly quickly, which is great. Now, let's say that we wanted to do kind of what I was thinking to do with this design, which is, okay, then we'll just place down another floor on top of that. And we've got a gap. So it seems like the blueprint designer kind of is reading this as being maybe a little bit taller than it actually is. Maybe it's gone to the very top of the smelter's clearance box now that I think of it. Because, again, if we've got enough resources to load this up in the blueprint designer, hopefully we have. One thing that we did have going on with this design was a little bit of clipping through the top here. You can see the highest thing isn't actually the foundation we used as a roof, it's like this little top of the smelter here. So maybe that's what's going on now I think of it, is the blueprint to blueprint snapping is kind of detecting, hey, you've got this little thing on top, I can't, or I shouldn't clip through that, and maybe thinking that instead it should go just a square higher. That's like center aligned, but you can see we've got this gap here. If I toggle out of this mode and go into default mode, you can see we are now soft clipping and it's perfectly happy. That works. It's just incredibly easy to misalign this, especially if you're building without being at the exact right height to do it. So we do get that there, we get the desired effect, and in this case I have been able to place it in the right place, which is good. When I was kind of messing about with this and practicing a little bit, it was super easy to get the foundations misaligned by not an entire square, but just like one tick. So you had this overhanging by like 6 inches, which looked really, really poor. Let's clear this out to get our resources back. The other problem that we kind of have with this design, and it's not a problem with the smelters, but is a problem with the constructor design that I did the same thing with, is having this kind of cube where everything's encased is a nice idea. And I do like the idea of it being, hey, here's just a modular like section of factory. How would we do this? We'd rotate so that the output for the smelter faces the input for the constructors. If I go back to blueprint mode, that'll align more easily. So that works okay. The problem came when I tried to turn any of this stuff on and get it going. What we actually have is machines clipping through these walls here, because obviously the size of this design is so tight, everything's kind of packed in the same way as it is in the smelter design. You've got stuff coming right up to the edge. And so in fact you can see it just there in the center of my cursor. Went to photo mode so we can zoom in. That's actually the edge of a constructor clipping through here. Looks a little bit naff once you've noticed it here, but it looks really terrible when the thing's powered up and actually doing work because of the animation on a constructor where that arm is continually moving. We've got a bunch of stuff poking in and out of the sides of the the design. I guess we can get around it by not having walls down here, but then that kind of, you know, messes with the whole purpose of having this kind of boxed off cube design. So yeah, I'm thinking a couple of things. I'm thinking maybe we want to amend the smelter design to include this layer of foundation at the top, so that at least we are going to consistently be able to stack floor on top of floor like that. And thinking maybe that instead of the 8 constructors which we've got in here, is there going to be an easy way to get up there and take a look? If we... oh, let's drop down a lookout tower here. That might give us enough height to be able to tell. So it did seem like I could fit 8 constructors down within the same basic design. You know, constructors take up an entire floor tile. We've got a 4x4 grid. So they're packed in quite closely as the smelters were in the smelter design. But maybe we need to back off this a little bit if we are going for this kind of walled off design, just so that we don't get the arms clipping through and looking, you know, pretty horrific as the machine works. So yeah, I think that's kind of where we are right now with blueprints. Is maybe need to do some tweaks to this basic concept. Maybe fewer constructors. Maybe want to make sure we're always adding not just a layer of foundations as the roof, but where something's poking through the roof, as again the top of the constructor is here. Maybe we need to go too high within the blueprint there, so that we don't get that weirdness where the snapping blueprint design wants to stack on top of each other with a gap. And yeah, let me mess about with that a little bit. We'll come back and see where we get to with it. I do want to, in this episode, tackle the bottom floor of our iron construction here, where we've got smelters running into constructors, running into more constructors. I do want to get rid of that and move to this kind of more modular design using blueprints. I'm just not too sure whether we've got the right design for blueprints yet. So yeah, let me take that. I'll do some experimenting and we'll come back and see where we're at with it. Alright, we're back and have made some progress. So yeah, did some messing about with blueprints in this little sandbox area we've created here. And I feel like I've got a better handle on what goes on with the snapping between different blueprint designs now. And I've made some changes to accommodate that. So let's take a look at what we've got here. Floor design's unchanged. Construction design, I took our basic smelter with no recipe. I added an extra layer on the roof so that it's no longer clipping through the top, and that means that we can now take this design and just stack them one on top of the other on top of the other. So this is the extra roof layer so that we don't have, when we see it, this problem with the top of the smelter poking through, which is what was causing that gap when we tried to build using blueprint mode. One thing that means is it's much harder to actually get in and access the smelters here because we can't do the recipes from the top. We would have to jump in through the door and get into the maze of stuff in here. So given that we don't use smelters for all that much, actually what I've done is just break those down into distinct recipes here for the common ones that we're going to use. So smelters, we now have 270 iron and 270 copper presets. Similarly with the... oh no. Okay, let's clear. Then try... oh, then pick up our stuff and try and load. Cool. Similarly with the constructors, I did, as we discussed, take that down from 8 constructors to 6. So there's more space in between each constructor within here, and really important, we no longer have these arms at risk of clipping through the edge of the design. Again, it's going to be, you know, a slight pain to have to like run through here and set all of the designs every time, or set all of the recipes every time. So as with the smelters, I set up basics of the recipes that we're going to be using most often. So iron plates here with details over on the right in that info pane I've added in the description of the blueprint, which is really handy. How many it takes in, how many it puts out. So plates, rods, screws going with that alternative cast screw recipe, so there's no need for the intermediary rod stage. Copper sheets and cables. We definitely do more with constructors at this stage in the game than just those. If we look at some of our constructor recipes, I didn't bother to go through and set steel beams and steel pipes because we're not really doing those at scale yet. I didn't set wire because we've actually got a few recipes for wire based on what the resources we're working with. So in those cases, I'm thinking I'll probably just put down the default iron plates one and then run through and set the recipes by hand. We're going to be doing this, you know, regularly, but not that regularly that we really need to worry about future-proofing every single one. And similarly, I didn't set blueprints for constructors for concrete or quartz or any of that stuff. But we'll play that by ear based on how much we actually are going through and using these, and using this specific design as well. The other thing that I did was over here, which was our basic iron input. So we had 2 miners running into a row of smelters down here that were running down this way, and then we had our basic constructors for plates here, and rods and screws here feeding up into the next floor, which is doing things like reinforced iron plates and rotors. That's all now cleared, ready for us to work with here. So let me take a look. In fact, one thing that I want to do before we go in and start building anything else is to make some changes to colour scheme, because the default kind of orange colour scheme is nice enough, but you see it everywhere. So I do want us to have something a little bit more distinct here, and we can do that by coming into the customizer, which we unlocked a couple of tiers of technology back. These swatches give us kind of options for different things, so if we want to, as a one-off, paint something in a different style, then we just select the swatch here and then target the machines that we want to change. We can also just set our defaults, though, in here, which we're going to do. So let me grab some codes here. This design that I think will look pretty good, hopefully. Let's see how that looks. So with that being the default swatch, it automatically applies to everything that we have built so far. Yeah, I like that. I think we'll go with that, at least for the time being. And I do want to do more with using the different swatches to designate different areas of the world as we go on, just to make things a little bit more visually distinct. So yeah, basic iron setup. In fact, what I'm going to do right now is just save this very quickly. And that's because when working with blueprints, there is no undo button, which would be a really nice quality of life that I hope Coffee Stain are considering. Because when you place down a design like this, when you have enough resources, it's going to place a whole bunch of items, and at the moment, if you make a mistake in terms of where you place it or the orientation or anything like that, and you want to get rid of it, you have to go through and delete, like, this would be delete 10 smelters, delete all of the power poles, delete the mergers, the splitters, the belts, the walls, the foundations. So it's quite a chore if you place one of these wrong and just want to reposition it. So saving before positioning is something that I'm learning to do with blueprints. So what's the easy way? So this is still quite finicky. I think the best way to do it will be if we get rid of a section of floor here. 2, 3, 4. And use our foundation blueprint, because that'll be the easiest thing to just snap into the middle of another section of foundation like this. Align with the center, there we go, that should be all in line. And then we can just use blueprint mode for the smelter and constructor cubes, so it'll snap to this section of foundation that we're looking at here. So just going to tap R to change this. And then, oops. Do want to make sure our input's on the right side. We are 1 input and 2 outputs with these builds, so that would be right. So then that'll be ready to just take a feed from a miner like this with a belt straight into the input there, and then when we power it, we should, right out the other side here, get our 2 outputs, giving us our 270 iron ingots per minute. So really, really quick and easy build there. And what I'm thinking, because we've got 4 iron nodes down here, we've got the 2 we've been using, and a spare one here and a spare one there, is that we probably want something like maybe a row of these running down here. So we'll just run a stackable kind of run of belts all the way down here and just have the 4 of these cubes, or maybe we'll have 1 here and 1 here, and then another 2 further back here and here. A little bit unsure on that there, but the ultimate goal here is that we'll build smelters on the ground floor, and then, given our design is stackable, build the constructors on the floor above there, ready to we'll just run lifts out of these outputs here to take the resources up over and run those into our constructor floor, and then we can just keep going up like that with these kind of modular units. Space-wise, if we're doing a 4x4, or sorry, a 2x2 of these, so 1 here and 1 here, I think we need to extend the platform in this direction slightly. And if we're doing a full run of 4 of them in a row here, we'll need to extend over into this area. So that probably will take a little bit of playing about until I get something that I'm happy with. And the other thing that we're going to want to do is to remove the floor that we've got above here with our assemblers, because it's in the way of doing that kind of vertical design like I was talking about. So I'll clear all of this out and do some experimental with placement of these blueprints for the smelters, and then we'll check back in. Okay, so we're back, and progress has been made. So first thing that I did was to reorganize our main storage here into this location right in front of our hub, and that's because we're going to need a bit more of the space over here in this direction. So I've extended the platform out a little bit in this direction, and then got to placing down these blueprints. So these are our smelter blueprint design, 4 of them, with the 10 smelters each in here. So I got those placed nicely by placing down our 4x4 foundation grid first in here, and then just using blueprint mode to snap those on. That now works quite nicely, and they should stack quite nicely as well. So that if we did want another design on here, so long as we turn it to blueprint design, we've now got good fit with no gap at the top, which is what we're going for. So we've got 4 of these down here because we have our 4 iron nodes, which I've got miners on all of them now. Belt work is ready to be hooked up. I ran a couple of the belts under the floor here with these little inputs. And then I'm using stackable conveyor poles to run the belts down the line and drop them off at the input of each iron smelting modular cube design. So that runs us all the way down to here with our 270 inputs on each of these. Using some signs as well for organisation. I need to drop those around the other side for the outputs, just to help us keep track of what we've got coming from where as we build. In fact, I should put them above each individual output like this. And so these are going to be iron. Let me grab the settings from the other one so that I've got consistent design. So just like with recipes, you can copy and paste using Control-C and Control-V for these. And that's going to be, we're splitting the 270, it's 270 into 270 out because iron ingots are a 1-to-1 ratio, but we're running 1 input in the center into 2 outputs, 1 either side, so that's going to be 135 from each. And that's going to be true for every one of these, so we're going to have 8 outputs with 135 iron coming out each. There's a couple of dependencies on that. We need to have enough iron coming in, which we can do with Mark 1 miners on pure nodes, but only if we overclock them. These are going to default to 120 per minute. If we want to get to 270 in each, then it will take us 3 power shards per miner, so we're nearly overclocking these to the max. It's pointless overclocking them further than that because 270 is our limit for belt throughput at the minute. But I will have to go and do some slug farming to get the extra slugs for the extra power shards here. So yeah, that's the big progress really from from last time we looked at this. The next step really, oh yeah, one more thing while I do remember is we are out of the experimental server and we're into the early access build now. That went live a week ago, 2 weeks ago, something like that. Which means mod support is back up and running. So I did add in the extra 300 inventory slots. So if you notice that I've suddenly got a lot more space and I have to do a lot less running back to storage, that's why. It's a really great mod, really great non-intrusive mod. So if you are interested in that, then just grab that via the Satisfactory mod manager. Yeah, so our next challenge really is to figure out what we're going to take this iron output and use it to turn into. We have our blueprints for iron rods, which are 90 in, 90 out. Iron plates, 180 in, 120 out. Cast screws, which will take slightly, well, will take 75 iron and turn it into slightly less than 300 screws because of belt throughput now. And then beyond that, we've got to take screws, plates, rods, and maybe some cables and wire and stuff like that. And really what we want to get ourselves to is the tier of assembler built stuff. So reinforced iron plates, rotors, and modular frames is really what we want to get out of our iron build here, all of which is a multi-stage process. Thinking about how to do the iron plates and iron rods, though. You know, I built these kind of modular cubes to be stackable like this. These, again, it's one input on this side and two outputs on the other side. But I don't think any of our ratios here are 1-to-1, so I don't think I can just drop this down and then run a lift up from, run a lift up from here and connect it straight into that input. I don't think any of our ratios are friendly enough to work with. So what we're probably going to have to do is to build ourselves a run of foundations along here. Maybe one, maybe two wide. And then use this run, so if our lifts are coming up through conveyor floor holes in this sort of location, run these into a series of splitters and mergers to balance the output, each of which is consistent. We're getting 135 out from each of those blueprint smelter outputs. And we'll have to do some running down the line and splitting into the inputs for the conveyor modules, which will sit above here. So I'm going to have to do some working out of that, and the ratios might not be friendly enough that we can just stack down 4 of those modules. You know, one here and one on the next one and one on the next one and so on. We might need to go multiple tiers high. We might need to expand off onto this side as well. So yeah, I'm going to do some playing about with that, and we'll see how we go on that front. Yeah, so that's progress, but we're still got some work to do. I don't have all of this hooked up as yet. I'm planning to do the entire build, and then we'll just run the final power into everything and belts into everything so that we can see all of the outputs running through at once. So yeah, good progress so far, and check back in. We'll check back in on the recording in a bit, when hopefully I've figured out what we're doing with the next stage, which is construction. Okay, we're back, and we've made some progress here. First thing to run through is that I've started to automate processing of the resources that we've got into our new storage here. This looks kind of like a spaghetti mess right now at first glance. It's more structured than maybe it does appear. Basically what I'm doing here is using the industrial storage containers with the 2 inputs here and stackable conveyor poles. So to set up something like this, it really is just a case of kind of add a storage container with the input going this way, like so. Add a stackable conveyor pole, and again follow that rule, which is from the center line here, move it back 2 spaces, and that'll give you the nice 90-degree turn. To try and keep the belts away from floor level, I've been running them into the top one. So the lowest run that we take, which is at this level, the first stackable conveyor level, is just running from there straight into the top. And then you do the same thing, but you do it 1 step further back and do it at the next level up, and then just keep going from there. So then the third one would be from there and running in, and then from there things start to get a little bit steep, so that's where we start to use conveyor lifts, like you can see here. So from going 4 layers high, just run that at that height. And again, if it's 2 steps away from the center, you'll always get that nice 90-degree turn. So there's not actually as much going on there as may first appear. The most complex bit really is just kind of ordering these and knowing, okay, we're going to run iron plates in here, so that needs to be our lowest tier that we're going to run this at. And we're going to have rods next, so that needs to be our second lowest. And then if you've got multiple lanes like we do here, saturating the furthest away lane with the furthest out run of conveyors, and then the second furthest away lane with the second furthest out run of storage containers. So yeah, hopefully that makes sense. All of this stuff in terms of cables, concrete, copper sheets and wires is everything that we had running into our more basic storage in this area previously. And then everything that'll run down this side is our iron plates, rods and screws, which is the production we're going to take a look at in a sec. And I've added space at this end for reinforced iron plates and for rotors, which is the ultimate goal of this next level of automation that we're doing over on the iron construction. This has grown a bit since we last saw it, so let's have a quick walk through. On the ground floor here we have our goods in for, this is actually raw iron ore, turning it into ingots. This is our modular blueprint here with 10 smelters each, and we've got 4 of those, so there's 40 smelters on this ground floor. Yeah, that's feeding in from this side and outputting on this side. And nothing's changed about that since you last saw it, except that I've added some of the belt work to run these down to this end and to then lift them up through these conveyor floor holes here. This was my first time using the conveyor ceiling mounts as well, and that's like super straightforward. It's a really, really good improvement. Basically all that you do is kind of run something out. If you're running it into a lift, you lift it to the appropriate level, and then as soon as you start to run a belt work that can snap, it just adds the ceiling mount to you for you like that. So that's great. That's a really huge quality of life improvement, because running belts at high levels used to be a big pain. So we're taking our outputs here. This is as many as we need so far, which is the first 1, 2, 3, 4, 5, 6 outputs. So we've got 1 entire smelter module that we're not using any outputs for the build right now. Those are running down through floor holes here and running into an array of splitters and some mergers in here, because the ratios aren't quite as nice as well, I mean, they're fine, they're manageable, it's just we have to do a little bit of load balancing here. So for example, our first output of 135 here is going in to a iron plates module, which requires 180 goods in. So that'll be 135 running on this belt, being merged with from our conveyor lift. That's lifting another 135, splitting it 2 ways. It's going to try and split 50-50, but what we're going to end up with is we've already got 135 here and we only need 180. So this belt will eventually balance itself down to 45. So then of this 135 that we're lifting, the rest is going to go in this direction, and that's going to be merged. So we're going to have 35 minus the 45, that's going that way. We're going to have 90 going in this direction, and merge those with another 135 coming up here, and that's going to flow into this one for our 180, and with some more from up here and that sort of thing. So I'll not talk through all of the ratios and all of the balancing in detail, but what we have got is a blueprint module for iron plates here, a second one for iron plates here, one for iron rods here, and one for iron rods here. So that's going to give us a decent amount of plates and rods. And then up on the next level, we're doing the same thing, lifting raw iron ingots up from the floor, just passing up through conveyor floor holes to go up to the second story. And these are going into screw production. So our screw blueprint, which I don't know if we've looked at in detail or not. Screws are 6 constructors with the cast screws recipe, so each blueprint takes 75 iron in, and that'll turn that into 300 screws. So we've got 2 of those running. One here, and one here, for a total of 600 screws that we're producing. I'm thinking we will need more screw production at one point, so rather than have a mix of resources and resource and construction types on this floor, I think I'm just going to keep this space, which is space enough for 2 more of these modules for whenever we need screws for anything, which I'm sure we will run into. And then we've got some walkways, some jump pads for getting around. On the output side of these, I've given myself some platforms to work with, but I haven't yet done the belt work and the merging and that sort of thing up to the next stage of construction, which is what we're going to have up above on this next level. We're going to have a 3rd floor, and that's going to have our assemblers, which will take the screws, the rods and the plates that we're producing and turn those into some more advanced iron parts. Which iron parts, I hear you ask? Well, if we switch over to this view, this is an incredibly awesome web app. It's at satisfactorytools.com, and what it is a production planner. It's really great. I can't recommend this thing highly enough. If you're new to this, how you use it is you just come in to the calculator tab, you add a new production line, and then you search from the available things what is it you want to produce. So if we were only making rotors, for example, add that. How many rotors do you want to make per minute? And it'll give you your entire production line. However, if you have any alternate recipes unlocked, like for example if you have the steel rotor or the copper rotor recipe, it will calculate for you what the best way of doing that is. So for example, we have a casted screws recipe. So if I add in that we've unlocked that, you can see it's then giving us the slightly different path here saying, oh, you can smelt your iron straight into screws and do it this way. It's really good because it tells you how many of each material you need, or each item type, and also how many machines you need to do this. So the build that we're going for here, if I get rid of that one, is this one here. I don't know how many of these we need, I just know that we're going to need a reasonable amount of modular frames, rotors and reinforced iron plates, which is kind of the next complexity tier of iron production. So I've put in as a starting point, let's just produce 10 of those per minute. I fed it in the recipes that we have access to, and here was the output. So if we were building everything ground up from scratch, not using any blueprints, then here's all we would need to do to get that exact output of 10 rotors, 10 modular frames and 10 reinforced iron plates. Would need to take 472.5 iron through realistically 16 smelters. One can be slightly downclocked, I guess. And then would need to make this many iron rods and this many screws and this many plates, and then we'd need these many assemblers with this many different recipes to put it all together. Given that we are using blueprints at this level, smelter level and constructor level for these, what we're going to do is actually create slightly more of each. We're just going to have, rather than go in and say, hey, we have 6 constructors in our iron rod blueprint, let's create another 2 of those that live outside that. What I've done instead is just put down 2 full blueprints of this, so 12 constructors for rods, and we'll create more than we need, and we'll just send the rest into storage, or we'll have the rest there as a line that we can tap if we need iron rods for something in the near future. So this is what we're aiming for. To do what we need to do in terms of 10 of these, 10 of these, and 10 of these, we need 150 iron plates per minute. We need 300 screws and another 250 screws per minute, so 550 screws in total. And we need 50 rods here and 60 rods here, so 110 rods total. So that's what I've got set up and ready for us. Where am I? So here's the board that I'm using to keep track of this stuff. Here's all the iron we have available. Here's what we're producing so far. So we need 150 plates, 110 rods, 550 screws. Here's what one blueprint produces for us. So, or two blueprints, sorry, produces 600 screws. Two blueprints produces 180 rods. Two blueprints produces 240 plates. So yeah, the next stage really is to come up here to where our screws on this floor and our plates and rods are being produced, to get those lifted up to a next floor that doesn't exist yet. Do some merging, splitting and load balancing, and create our assemblers on that floor. So those are the, just flick back and check, the 5 assemblers we need for the reinforced iron plates, 5 that we need for the modular frames, and 3 assemblers that we need for the rotor. What we'll do at that same time as we're doing the load balancing for the inputs for the assemblers is split out the excess rods, plates and screws that we've got and run those online over here to our main storage. So we'll always have a steady supply of the basic iron components ready for us to just come and grab anytime we do run out or want to build something. So yeah, getting ready to connect the outputs here. We'll put another floor on top with those assemblers, belt everything up with conveyor lifts, do our load balancing, and then we'll have our overflow of our basic parts, the rods, the plates and the screws, come down and connect onto these lines here to go into storage. And we'll also belt out the outputs of our assemblers, which are going to be the reinforced iron plates, the rotors, and we actually need one more here for modular frames. So let's add that as well. So that's going to be the next stage. Hopefully that all goes nice and smoothly. And when you see it next, that stuff should all be ready to connect up the power and set everything going. So yeah, let's check back in a bit and we'll be ready to have the final output of our iron refactored factory here. Okay, several hours later. I think we are about ready to hook the last 2 things up here and then flip the switch. So yeah, it's still the same starting design. It is in there. Here's our smelter blueprints that we started with. So what have we got? We've got a floor here which is entirely smelters, and then a floor here which is entirely constructors with 2 of the iron plate blueprints and 2 of the iron rod blueprints. We've then got a floor which is half populated here with 2 of our screws blueprints. And all of those are being belted up over to this new top floor right up here. So let's go and take a look at what we've got going on up there. So yeah, this is complex. It's nowhere near as complex as it may appear. One thing that this kind of blueprinty cube design pushed me into the way of thinking of is building more compact. Like something like this, traditionally I would have done much more spaced out, probably across multiple floors, as well as with more space in between all of the machines and with extra space dedicated purely to running belts around for input and output and that sort of thing. So it's been a little bit of an interesting challenge to try and do all of what we're doing here within this much real estate. So if you remember, what we're going for here is 10 of each of the assembler recipes. So 10 reinforced iron plates, 10 rotors, and 10 modular frames, and the modular frames themselves require some of these reinforced iron plates. Yeah, so what we've got is plates, rods and screws feeding up here into assemblers making reinforced iron plates, and we have, if I remember rightly, 8 of these. 3, 4, 5. 5 making reinforced iron plates, each making 5 per minute, giving us a total of 25 reinforced iron plates. What we're using is 15 of those to feed into the build for the modular frames. Along here we have our 3 assemblers making rotors. One of these is downclocked by 50%, so that gives us our 10 rotors per minute across the 2.5 assemblers that we've got running. And then, as I said, in front here we're taking 3 of the reinforced iron plate outputs. That's the lower line of mergers here. Running it to the end and running it into this splitter, so all 5 of them run into here, and what this should balance itself out to is we should get the output of 2 of them onto our output line to go back to main storage here, and the output of 3 of them, so 15 reinforced iron plates, to go into our 5 assemblers here, making the reinforced iron plates, which gives us our 10 per minute. So yeah, some of this belt work was a little challenging to do. Anytime you see something like this, really the way that it was kind of done is with stackable conveyor poles like this, so originally like that to place them. And then I don't like having too many of these, especially in short proximity to each other, because there would have had to be one probably like here to get the turn right for this one, and then there'd probably have to be another one about here to get the turn right for this one. So what I do is use all of the stackable poles to make it and get the turns right, and then I tend to delete most conveyor poles. I might leave the odd 1 or 2 in there if it's somewhere that looks kind of natural and sensible like this one does. But generally I don't like having too many of these lying around. I like the kind of free-flowing belt look, so I will tend to do that. Yeah, so all of the outputs are running down from furthest away to this direction. Up top, this is our output line for the modular frames. In the middle, this is our output line for the rotors, and then at the bottom, this is our output line for the reinforced iron plates. And these are all running down to this little array of, if I can get in there, conveyor lifts, taking it all the way back down to our main storage. So yeah, that's kind of what's been done. Everything's belted, everything has power connected internally, but I've not connected this to the main grid yet, and I've not yet connected the inputs in terms of the miners yet either. Those miners are ready. The 3 of them, I went out and got sufficient slugs and made power shards such that we can't overclock them the way that we're going to need to. So, fingers crossed, all we need to do is connect the last couple of belts, and then give it some power. The other thing that I've been spending some amount of time with here is decoration, which does kind of move us away a little bit from the, you know, the cube design that we were looking at. That's still in there, but really this is, it's kind of one larger factory unit, and I've kind of collected it together as such. These full frame windows, I went ahead and unlocked those in the awesome shop. So I've got some more options here. Got some glass and some mixtures of glass and the basic wall, the kind of metal look. And then these things here are just the 1 meter high wall, which I've never used for decoration before, but I actually think is really nice. Before I settled on the glass look, I kind of had these things where I was like doubling these up out in the open air to make like kind of a little balcony kind of view, which I also quite like the idea of, so I may come back to that and reuse that sometime. And then, yeah, up top I've left things out in the open. 1, because it's not using our blueprint cube design for the assemblers. And 2, because we may need to expand up there at some point. And 3, I just kind of like the look of this mix of like, hey, everything's polished and tidied away, and then, ooh, industry is happening up here. I'm not so sure about having this run out here for the outputs. That needed to be there for me to run the belts, but I am leaning towards, let's get rid of these foundations, get rid of any of the conveyor poles that are now hanging on to nothing, and just embrace that kind of free-flowing belts look. So yeah, let's go ahead and connect things. We've got our inputs ready for the iron ore, one of which there, and then the other two are going to feed directly onto... One feeds directly to this belt here, one goes underground here. Oh no, I need some steel beams. That's inconvenient. So while I'm going and grabbing those, let's consider the fact that we have got that glass design there, and had a bit of a choice to make in a couple of places as to whether we're going to do what we're just about to do, which is run a belt through where the glass is. If there was a nice, you know, we've got conveyor walls and that sort of thing. If it was possible to do those in glass, I would love to have a glass window and just run a conveyor hole through it. But as we're not, it's either a case of have a missing pane of glass, which looks quite jarring when especially when you see it from a distance, or to just cheat it and run the belt through the glass, and pretend there's some really expert, intricate glass cutting going on there. I did run one of the conveyor lifts up to one of those glass panes, and it's actually the edge of the glass and the start of the belt that feeds from it is where the glass divide is, which that looks really natural. Like I don't think anyone would ever notice it if they didn't know it was there. I think this one that we're about to do in terms of feeding into, yeah, is going to be less obvious, more obvious. So, but we'll try it and see what it looks like. If we have to remove a pane and maybe just put like one run of walls in with a conveyor lift hole, then we'll do that. See, I know it defies all of the laws of physics, but I think that doesn't look too bad. Let's try the alternative at least. What are we gonna want? One wall. Should at least connect that properly. Doesn't look too bad actually. Maybe if we get rid of the windows above it and replace those with walls, and then it'll just be a, you know, like a feature wall, like factories have. I think that looks alright actually. I think we'll probably do that and then probably do the same a couple in from this end for some symmetry. And in fact, that can even give us one thing that we're lacking, which is a door on this side. Yep, okay, I like that. That's the way to go. And as that's a wall, that gives us a handy point for the last thing that we need to do here, which is power. Are you connected to our main grid? This line? Yes, you are. No, you're not. I did this before where I disconnected the coal power accidentally and ended up running on the biomass burners, and I just want to be sure that we're not doing the same thing again here. No, they're burning. Why are you burning? Oh no, they're not. They just look like they are. Still got 200 in here. 200. 200. 200. Yeah, okay. I should really note from the production, actually, 1200 is way too many to be this this run of biomass burners. Right, these would give me, what, 30 each? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. So, about 400 and something megawatts. Yeah, that's how 1200 from our coal power. Okay, cool. Right. So, yes, as I was saying, we've got power here, which is connected to the main grid. We can then just grab a double wall outlet, which is good. I was thinking I was going to have to find a way of running the power through the glass, which, let's take a look, but I assume looks pretty rubbish. Not as good as if it's running through a wall, certainly. So, just need to run that. And then get rid of our little note to self. And then, fingers crossed, once I connect this, everything should start to run as it's expected to. Hold on to your butts. So it'll take a few minutes to start seeing everything doing what it's supposed to. Let's put a door in here as well. Why not? So we should have 270 iron ore running into each of these. That I'm fairly sure will be true because I've overclocked the miners. These guys should all be being fed, and the last couple in the run should slightly starve. This is built to take 300 per minute, and we're only feeding it 270. And that 270 in should become 270 out, and start feeding its way up to the next floor. We have ingots coming in here, feeding their way into this plant, which is plates, and this plant, which is plates. And then if I balance the loads properly, it should eventually break itself down and start sending 90 per minute into here for rods, and 90 per minute into here for rods. And then each side of that should give us 45 rods per minute. We're seeing rods come through, which is good. And what did I do? That's few enough rods that we're able to run them on one output line, like this, and go down to a lift. Plates, we're getting 60 from each output. So again, ran them down to one line to go up in this lift. And they're skipping the next floor, which is screw production, and going all the way up to the top floor for the assemblers. On this floor, we have our 2 screw modules. That was an overeager jump. We have our 2 screw modules being fed ingots, but not doing anything because I neglected to supply power here. Where should you hook up to? That power pole, probably. Right, so 75 ingots each going into these, generating, if I remember rightly, 300 screws each per minute. So we should see 150 come out here, and 150 come out here. And again, feeding down to this end. And that's... Is this my overflow? It seems to be going straight out down to main storage, so I guess this is my overflow. And then the rest getting lifted up through conveyor floor holes up to the top, and some went this side as well. Too many screws all told to run them on one main line and up through the floor the way that we did with the plates and rods. And then on the very top, we also don't seem to have any power connected. That's going to be a problem. I'm kind of trying to do it without clipping any power cables through anything. Yeah, it misses the ladder. That's good. Alright, so hopefully everything does what it's supposed to here. We can see rods coming through. Some of our rods have to come in here to make rotors. The rest of them overflow around this way to go into the modular frame assemblers. We got screws coming in to the rotor build as well. These need to be Mark II belts, and they are. So we should have some rotors being outputted. Our reinforced iron plates, everything is green up top, which is a good sign. We got iron plates and we got screws. This is looking good. Reinforced iron plates are coming out of the overflow and going into storage. That's good. They should also be being split this way to go into the modular frame build, and they are. That seems like a failed experiment at a... That's probably why we have no power up here. I probably placed that, thought it looked rubbish and decided to do something different, and then forgot. We got green lights here, we got yellow lights here. If these are fed left to right, that would make sense. Because these guys are still waiting on resources. And it will take some time to like load balance itself, especially because we are just kind of relying on, for example, this run here, which is the output of our 15 reinforced plates per minute. We need to split 3/5 this way and 2/5 are fine to go into storage, but we can't do that with the technology we have today. This is a perfect 50-50 split, so it's going to take some time actually for that to kind of balance itself and for this to get enough of what it needs to. We're just going to live with that fact. We're going to make our peace with it. Later on, we will unlock smart splitters, which let us do things like prioritize one output over the other, or we could do something very complex with multiple splitters and mergers to load balance. It's not worth it now. It would increase the size and complexity of what we're doing with beltwork here many times over, I think. But if I drop in some reinforced iron plates here, we should be able to see that work in itself. Those should come straight out and split in high enough volume that we should be able to see the entirety of this run of modular frame assemblers turn green, which really, once I've seen a green light on everything, then I'm I'm happy here. So long as we start to see some outputs run down the belts and run into storage as well, of course. Which we are now seeing. Those are modular frames. Yes, yes. Those are rotors, those are reinforced iron plates. So I think if we take a jump down here, hey, there's some modular frames. In storage. Rotors, I already had plenty in storage, but we should see this number going up. Nice. And again, you can see we have some reinforced iron plates ticking up here as well. Awesome. That worked pretty darn well, if I'm being honest. Yeah, a couple of places where I forgot to run the power to. So it always does just pay, especially with a build this complex, to do a kind of run through. Make sure that you can see what you're expecting to see at all points. If there is a glitch in that system and I've neglected to power something, then all that will happen will be we'll get less output than we expect to, which is something that would be quite hard to track right now. But I think we're good. I think I would call that a successful build. So yeah, that is basic iron is now done, recreated. We have everything really that's in our starting storage is now automated and feeding in. We've got plates, we've got rods, we've got screws. We've got reinforced plates, rotors, and modular frames. And then from the other side of the build, which we haven't touched, we have concrete, copper sheets, wire, and cables. So yeah, things are looking pretty good. Let's go and unlock a milestone before we call it a day here. That improved melee combat is going to give us
R&D inflated your pocket dimension, added an additional handy
some extra space and an extra hand slot, which is nice.
with increased strength and range.
And an extra, yeah, the Xeno Zapper, if we were not playing on passive mode, would be a really substantial unlock that would be very excited to get. As it stands, we'll make one, but you know, we're not going to be doing much harming of enemies. So what's next? We got tractors and truck stations, and now we've got modular frames and rotors and things in volume. We can get into these tiers as well, which is pretty exciting stuff. That's for next time, though. We're going to call it there. So, as always, thanks for watching, and I will catch you guys on the next episode of Satisfactory. Cheers.